So we're going to be looking at functions and relations today. A relation is basically a set of ordered pairs. There's an input, an x value, and an output, a y value. Now, ordered pairs, obviously you can write them as a set and in set notation. You can write them in a table to see their x and y values. You can use mapping notation, which shows your domain values and your range values, and you can show them as a graph. So, quick little summary of that. Let's say we use set notation. Set notation, you'd require curly brackets. And let's just say we had 3 and 9 as another pair. Okay, so there's my set notation. I have two coordinate pairs, two ordered pairs. I could write it as a table of values with my x and y's, which gives me my x is 2, my output is 4, 3 is my input, 9 is my output. I can also do it as a mapping where all my x terms go into 1, which is referred to as the domain. And in another circle I put in all my outputs, my 4 and my 9, and those are referred to as my range items. There's an arrow going from 2 to 4 with an arrow, and 3 to 9. That's how they're related. And of course another way of doing it is graphing it by finding 2 and 4 and 3 and 9. 2, 4, and 3 and 4, 8, 9. So that would be graphing, table of values, set notation, and mapping notation. All of that can be used for a relation. Now a function is a special type of relation where for every input, for every x value, there's only one output. The above example is a function. It has an input of 2 and the output is 4. There is no other instance of 2 being mapped onto something else. 3 gets mapped directly onto 9. There's nothing else that 3 gets mapped onto. Now, a one-to-one function is a special type of function where for each x input, it has a unique output, which means that two inputs can't share the same output. Now down below here we have 3 graphs. This one is referred to as a quadratic graph. This one is a cubic. And this one is a circle. Now we're going to be learning about these types of graphs and how to generalize these graphs, but we'll start off with just the overview of what they are. If we look at all three of these are generated with a bunch of coordinate points. So as a result, because we have all these different coordinate points that go infinitely along the quadratic, this is a relation. Same here, we have coordinate points, x and y values, that we could write in a table, and there's infinitely many as they go along the graph. And again with the circle as well, I have tons of points here that I can actually find, and I can say that is also a relation. So quadratic, cubic, and circles are all relations. These are not all functions though. So the circle, let's start with this one. A function is a special type of relation where there's only one output for each x value. So if I look at the circle, let's just say I choose this point here. Let's say it's -3. There exists 2 points. That would be my table of value. So if I wrote my table of values for my x and my y, for -3, I would have 2 possible values for an output. And just for number's sakes, I don't know, call it a and -a. So for one input, it does not have only one output. It has 2. So this one fails being a function. So this is a relation, and it's not a function. If I look at the quadratic and the cubic, let's look at the cubic first. For every input, any x value, there is only one y value that correlates. Let's say I take this x value, I only get one possible y value. If I take this x value, there's only one point where it touches. whereas here I would have 2. So this is definitely a function. It's also a relation. If you look at the quadratic, same idea. 1x value gives me 1y value. 1x value gives me a y value. Now, it's a little different in this case because these are both functions, but only one of them is 1-to-1. If you notice here, it kind of looks like in this instance here, it's not to scale per se, but I could make it work. For this, whatever this value is here, let's call it A, it does have a value here at B. This guy here, it's a C, we don't really know what it is, it's a negative number. It also could be going towards B. There's one output for C, and there's one output for A, but they can actually share the same output. So this is not a 1-to-1 function. The cubic function is, in this particular case, a 1-to-1 function. Okay. So let's take a look now at domain and range. Okay, so the domain is the set of all the x values with a given condition, and the range is a set of all y values with a given condition. What we're going to look at is proper notation. So when you do your domain, we always have to have the proper notation to start off with. And it's the same thing for all domain questions and for all range questions. What you have to figure out is the condition. What are the possible values that you can have for your domain? What are the possible values you can have for your range? Now, what this basically means is the domain is a set of, curly brackets, all x's such that condition. So when we look at each of these, we're going to have to analyze each one to figure out what the condition is. Now this again is a quadratic. We've already said it is a function, which means it's also a relation because we can graph it as well. What we need to consider is what x values work for this function. If we choose any value, it will graph onto a point, any x value. Doesn't matter where we choose it. There are basically no restrictions. Your x value can be a decimal, it can be a whole number, it can be a negative number, it can be a positive number. So it basically falls into the set of all real numbers because it can be any type of number. Now when you're looking at the range, we're looking at your y values. So if I choose any y value, these y values exist, they have a point, these ones have a point, they technically have 2. Down here we can have these y values, these y values. Where it becomes a problem is our vertex, we have one here, but when we get down here, there's no point. So this is going to restrict our range as a result. If we look at our y value, the lowest y value we can have is -5. So that means y has to be greater than or equal to -5. Now the types of numbers again can be whole numbers, or they can be decimals or fractions or positive or negative. So as a result, they can be part of the set of real numbers, but they still have to be above or equal to -5. If I look at the next example, this is actually referred to as a square root function. Okay, so for a square root function, you need to consider the domain. Again, you want to look at what x values are going to map onto the actual graph. So, if you choose any of these x values, they're going to graph onto the blue graph. Although over here, there is nothing that it's going to map onto. The main difference here with this graph is that it has a dot here, which means that it's not continuing on in a pattern, whereas here it has an arrow, means that the pattern is going to be continuing forward. So as a result, our domain is going to be restricted by the fact that at -6 there's nothing below it. So then x has to be greater than or equal to -6, and again you can have fractions, decimals, any integer, positive or negative, so it's going to be a value of the real numbers. If you look at the range, again we're going to be looking at the y values that are valid. So if you look at all the valid y points, if you take a y value here, there is a point on the graph. If I take a point here, there's a point on the graph. Technically, if I use any of these guys here, you're going to have a point on the graph. It's going to continue on that pattern. Where it stops, though, is towards the bottom here. There's no point again on this graph. So you're looking at your y restriction, which is based on the lowest point that it terminates at. So again, y has to be greater than or equal to -4, and y is an element of real numbers because you can have fractions or decimals because it is a continuous function. So again, if you look at the circle graph, this one is not a function. So if we look at the circle function, we look again in terms of all the x's that are valid. Now if you notice, it fails a vertical line test because for one x it has 2 y outputs. But we can still find the domain and range. All these values here are all valid because they at least map onto the graph of the circle. Whereas here, there's nowhere for it to go again. So again, the important point is the edge of the graph where there's no values for x beyond it. So now x is now contained between -6 and +4. So if you have -6 less than or equal to x less than or equal to 4, it's contained between these two numbers. Again, if you don't know your inequality signs, it's always eating towards a bigger number, right? And x is the element of real numbers. If you look at your y values, you have valid y values here, and then above this, there's nothing that it's going to touch. Same thing down here, we have some valid ones, but nothing below this point here. So if we look at our y terms, it's going to be between -6 and 4 again. -6 is a smaller one, it could be equal to it all the way up to +4, and y is going to be an element of real numbers again. So that's how you determine your domain and your range, and how to write it with proper notation, with set notation.